Exercise chapter 1.
Yes, we are going for solving the numerical question. Am I right?
Yes.
Okay. My screen is visible for you all.
Yes.
Okay. Okay, brother. Today we are going to discuss these 5 problems in chapter number 9. Question number 1, 80, 28, 42, and 50. Let's we start with the first question. Read the question very carefully before you answer. First of all, try to understand. Try to know what is given. Try to know what they need, and then try to work out. Understand, brother?
Yes, teacher.
Okay. So read the question. 3 particles of mass 1 kilogram and 2 kilogram and 3 kilogram are placed at the vertices A, B, and C respectively. That means you have 3 masses. You are placing these 3 masses at 3 locations of A, B, C. So if you just see this, you see the picture. You see the picture.
Yes, we can see it.
So my first mass, I place it here. What is the mass?
In A. In
1
point A.
kilogram. And I place the second mass at B,
2
which is nothing
kilogram.
but 2 kilogram. And then third mass I placed at C, which is nothing but 3 kilogram, as per the information given by the question. And they mentioned this is an equilateral triangle. Brother, what is equilateral triangle, brother? Have you ever heard about this triangle, equilateral triangle?
All of its angle less than 90.
45.
So all angle is exactly 60 degree. Clear?
Yes.
Okay. And then they say the sides of this triangle is exactly same for all the sides. That is nothing but 1 centimeter. That means from A to C, and C to B and A to B. What's the value? My value is 1 meter. Clear? And also we have to know the location of this mass 1, mass 2, and mass 3. Brother, what is the location of mass 1? It is exactly at the origin. Am I right? So this is 0, 0. Am I right?
Yes.
Okay, what is the location of B?
0 and 1.
1, 0. Not 0, 1. 1, 0. And what is the location of the third one? We don't know. Am I right? So we don't know the value of the C. So our x-axis value and y-axis value for the C location we have to find. Okay, let's continue reading. What we are going to find? We are going to find the distance of their center of mass from the point A. Brother, you have 3 masses: mass 1, mass 2, mass 3, and you are going to find where is your center of mass is exactly locating here. That means, suppose you consider if my center of mass will be located here, for example, what you are going to do, you are going to find what is the distance from point A to the point of the center of mass. That means you are going to find the distance from the point to the center of mass. For example, if you consider this is your center of mass, what you are going to do? You are going to find the value of R from the point A. This is our question. So first you have to do one thing. If you want to find the center of mass, first of all you have to find what should be the location of the third mass. Am I right?
Okay, teacher. The center of mass is to center.
What?
Also, it's equal to C to the center.
No, we don't know, brother. See here, the mass are different. My first mass is 1 kilogram. My second mass is 2 kilogram. My third mass is 3 kilogram. So we don't know whether
So
where
it
it
depends
is.
on the mass.
Of course, because we studied already. Your center of mass will be located in the near to the massive object. Am I right?
Yes, yes, teacher.
So we don't know these things. So what I am going to do, I am going to find the center of mass first. So if you want to find the center of mass, first of all, you have to find what is the location of the third mass. Am I right?
Yes. So we have
And
to
then
find C, and then we
and
will
then you have
find
to find the
center.
and you have to find the center of mass. Once you find the center of mass, you can easily find the distance from the point A to the center of mass. Clear? So three things we
Yes,
are
yes.
going to find. The first thing, we are going to find the location of the third object. The second thing, we are going to find what is your center of mass, and the third thing, we are going to find the distance of the center of mass from the point A. Clear?
Yes, teacher.
Okay. Better I can draw the diagram again. So this is my equilateral triangle. And this is my point A, B, and C. And point A to B is 1 meter. And point C to B is also 1 meter. And point A to B is also 1 meter. Now I try to want to split this triangle into two. By that, I can easily find my x component and y component. What is my x component, brother? My x component for this is nothing but L cosine theta. Am I right?
Yes, teacher.
And what is my y component? My y component is sine theta. So if you
Yes.
find the L cosine theta and L sine theta, that value is nothing but the location of the third mass. Am I right?
Yes.
So first of all, I am going to write what is given in the question. In triangle ABC, my AB, which is equal to BC, which is equal to CA, which is equal to 1 meter. And in equilateral triangle, all angles are 60 degree. If you just want to find the location of the third mass, my mass 1 is 1 kilogram, my mass 2 is 2 kilogram, my mass 3 is 3 kilogram. My mass 1 location is 0, 0. My mass 2 location is 1, 0. My mass 3 location we are going to find. Clear?
Yes,
Teacher,
teacher.
he want the position of mass 3.
Of course, because without knowing this or the location of the mass C, how you will find the center of mass?
Okay, so we want to get 3 positions.
Yes,
to-
then only you can go for finding the center of mass. Clear? Okay. Now, in triangle, my L cosine theta, which is equal to my angle is L cosine of 60 degree. Am I right?
Yes.
So, what is the value of L cosine theta? 60 cosine 60. If you type type in your calculator, your L cosine value is 1/2. Right? L
How
multiplied
could
by
we
1/2.
know it's yes? Yes, cosine 60, it's half.
Half.
1/2.
Okay, now we can see this L and this L get cancelled. So this cosine theta stands for the x position. Am I right? So what is the value of the x component of the mass 3? Is exactly half. Am I right?
Yes.
Okay. Likewise, y component L of sine theta. Therefore, L of sine 60 degree. It is nothing but if you just type sine 60 degree in your calculator, it becomes √3/2. So this L and this L get cancelled. So what is the location of my y object? The object third y
Square
vertices
root
is
of 3/2.
3/2. Am I right?
2,
So
yes.
we find the location of the third mass. What is my location? Half, comma, √3/2. Am I right?
Yes, teacher.
Okay. Now let me come for the center of mass. What is the formula for center of mass, brother?
Okay, teacher, I don't get why we cancel L.
Yes, how?
Yes. Brother, this is the total length is. Oh, okay. If you don't worry, no problem. You can leave because I said all sides are same. All sides are same. Am I right?
Yes.
That's what I put L cosine theta.
Which is mean if it is different, we have to write the L.
Yes, of course.
But
luckily,
now
but luckily in the question they clearly mention all sides are same. My L is equal to 1.
because all the sizes are the same, so we
Yes.
cancel the L.
Yes,
I get
right.
it now.
Here, okay. Now, what is the formula for center of mass for finding the x position? By finding the center of mass for the x position is nothing but how many objects you have? You have 3 objects. Am I right? So m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Am I right?
Yes.
We
Yes,
studied
yes,
this
teacher.
formula. Do you remember this formula? We studied the first in the first slide. What is given x?
M1 multiplied by x1.
Clear? So likewise,
Yeah.
I have to find the value for my y component also. What is my y center of mass? My y center of mass is also exactly the same. So y center of mass, which is nothing but m1 y1 plus
Y1
m2
plus
y2 plus m3 y3 over m1 plus m2 plus m3. Am I right?
yes.
Now you can see you have all the values. What is the value of m1? 1 kilogram. What is the position of
Yes.
x1? So this is your x1, y1. This is your x2, y2. This is your x3, y3. Am I right?
Yes.
So if you substitute all the values in the formula, you can get the x center of mass as 0.583 meter. Am I right?
Yes, but wait, I want to
Yes, teacher.
do the math.
You can work out and please let me know the answer.
Okay.
Three 3.5 over 6, which is nothing but 0.583. Got it?
Yes. Again.
Okay. Okay, brother, listen carefully. Likewise, after you find the value of x center of mass, you have to find the y center of mass. Now, brother, listen carefully. We find our x center of mass and y center of mass. So what should be the value? 0.583, 0.433 is our center of mass for the entire system. Am I right or not? So in this diagram, what is our center of mass? So this point is exactly 0.583, 0.433. Am I right?
Yes.
Now we are going to find what is the distance from the point A to the center of mass. So we are going to find the value of R. Therefore, from the point A, so how you can write my center of mass? You are going to find the magnitude, which is nothing but what is your x center of mass? 0.583. And what is the position of your A? 0 square, because you already studied this formula in chapter number 3 vector, or how to find the magnitude. Likewise, your y component 0.433 and your x position, your A position is 0. You have to find the square root. When you just find the square root, that will be the distance of the center of mass from the point A. Clear?
Yes.
Understand?
Yes, teacher.
Okay, that information is given in this slide. So please take a practice. Okay.
Yes.
Okay, let's become for our second question.
Teacher, excuse me.
Yes, please.
The magnitude is same the distance from the point A to center of mass.
Yes, because they clearly mention in the question. What is given in the question? Read the question. Find the distance of their center of mass from A.
Okay, but okay. But
Okay,
not
okay, let's
not
okay.
not mention the magnitude. Just find the.
My dear, listen. Suppose if I ask the question, find the center of mass from the point C. What you will do?
I'll take 2 points of C.
0.583 minus
Yes.
what is my x value?
I mean here, teacher, the point is y magnitude to
Yes.
get the distance by meter, right?
Yes, it should be in meter.
Not 2 point.
No, brother. Actually, from the point A, where is your point A located? Your point A is located at 0. Am I right? What is the location of A? It is 0, 0. Am I right?
Okay.
So from this point to your center of mass, this value minus your, that means this x value minus this square, this y
Yes.
value minus this y square. Am I right?
Yes, I get it.
Okay. Let's become for our second question. What is given in the second question? 0.7 kilogram mass, sorry, 0.7 kilogram ball moving horizontally at 6 meter per second. Brother, just to see the diagram, a person who is having the ball in his hand, and what he is going to do? He is going to throw the ball to the vertical wall. So you have a wall here. So he has the ball in his hand and he is throwing the ball horizontally, and the ball is moving with the velocity. That means initial velocity is given. What's the value? 6 meter per second. Am I right? Right or not? And
Teacher, close your eye.
after the ball hits the wall, it will be rebounds. It is coming back with the final velocity. Am I right?
Yes.
So here, the change in momentum is a vector quantity. You can see, if you consider the graphical part, this is your x-axis, this is your minus x-axis. Am I right?
Yes.
So your initial speed is going in the positive direction. Your final speed is coming in the negative direction. Am I right or not?
Yes, you are right.
What is your momentum? So what is the formula for change in momentum? My change in momentum formula is nothing but mass multiplied by change in velocity. So what is change in velocity? V final minus V initial. Am I right?
Yes.
So what is the mass of the ball? The mass of the ball is 0.7. What is our V final? Our V final is 3.5, but it has negative direction. Minus of, what is my initial direction? My initial speed is nothing but 6 meter per second. So what you will get? 0.7 multiplied by minus 9.5. Am I right?
Yes.
So 9.5 multiplied by 0.7 gives you
Minus 6 point.
minus 6.65 unit kilogram meter per second. Am I right? But what they give in the question, you have to find only the magnitude. So my magnitude value of change in momentum is nothing but 6.65 kilogram meter per second. Right?
Right.
Okay. Listen carefully. If you want to consider the diagram in the reverse way, what is the reverse way? Suppose if you have the wall here, the man is here.
Yes.
The ball is coming this direction. This is your initial speed. Am I right? And this is your final speed. Am I right?
Yes.
Now you can see my initial speed has the negative value. My final speed has the positive value. Am I right?
Yes.
In such a case also, you will get the same answer. Clear?
clear, doctor. Doctor.
Yes, but it will be in the positive.
But of course, your answer, because they need only the magnitude. So positive, always you will get the positive value. Am I right?
No, but teacher,
Yes, the previous
if I
one,
put,
it was
One by one.
minus
One
C.
by-
Yeah, yes.
What?
The previous one, it was minus 6.65, and we changed it to a positive.
Because brother, read the question. What is given in the question? What they need?
Yes, I know.
What they need? What is this?
The magnitude
What is the meaning for magnitude?
always positive.
Absolute value of the negative is positive. Am I right?
Yes, of course.
What is the absolute value of the positive?
Positive.
That's what both answers are saying.
Okay.
Clear?
Yes.
Doctor.
Okay. Yes, yes.
If the ball come to another place,
Not another place.
you know, I mean, the ball touch the ground, okay, with initial speed, and come to another place, not respond. You know what I mean? Here we just v final minus v initial, right?
Yes.
Okay, thank you.
Okay. Let's become for our third question. What is given in the third question? In Taekwondo. What is the meaning for Taekwondo, brother? Actually, this is a martial art in Korean country. It's like a karate. So it's a self-protection art. If anyone come and hit you, attack you, you have to protect yourself. Am I right? So it's a name of the martial art. So in this art, what they will do, they will use the hand and the leg. But in this question, they clearly mention only the action of the hand. So in this art, the hand is slammed down on the target at the speed. So what is your change in speed? Your change in speed is given. What is the value? 13 meter per second. Am I right? The hand is coming hit the target at the speed of delta v, which is nothing but 13 meter per second, and it is hitting the target by the time it has the collision. So the collision takes place the time difference of, what's the time difference? The time difference is exactly mentioned as 5.5 millisecond. What is the meaning for millisecond? 5.5 multiplied by 10 to the power of minus 3 second. Am I right?
Yes.
And also they clearly mention your hand is independent of your body. So your mass of the hand is given. What is the mass of the hand? They clearly mention 0.7 kilogram. Clear?
Clear.
Now what you are going to find? You are going to find what is your impulse. So first question you are going to find the impulse. In the second question you are going to find what is your average force. So we have two formulas for the impulse. What are the two formulas? We have the impulse formula as impulse, which is nothing but mass multiplied by delta V, and also I have the impulse formula as force multiplied by delta T. Am I right?
Yes, you're right.
So for finding the first question, I am going to use the first formula. Therefore, I, which is equal to mass multiplied by delta V, my mass of the hand is 0.7 multiplied by delta V is given in the question 13 meter per second. When you just work out with your calculator, you will get 9.1 kilogram meter per second, or what's the unit? Another unit? Newton second. Clear? So once I find the impulse, with the help of this impulse, I am going to find the B question. So we already know impulse, which is equal to force multiplied by delta T. We are going to find the force. Therefore, impulse divided by delta T. Am I right? So now what I am going to do, I am going to take this impulse, I am going to substitute here. So if you substitute, what you will get? F, which is equal to 9.1. And what is our delta T? It is already given in the question as 5.5 multiplied by 10 to the power of minus 3. So when you just substitute the value, you will get 1.654 multiplied by 10 to the power of 3. The unit for force is Newton. Clear?
Yes, teacher, clear. The impulse, teacher, has two formulas.
Impulse have two formula.
It's instead of the given, right?
Here, the impulse which is equal to average force multiplied by delta T. Likewise, my impulse which is equal to change in momentum. Right? So you have two formulas.
Okay.
Okay. This is our fourth question. Brother, please read the question very carefully. And this question is related with your collision also. You will get the type of collision from the answer. Brother, now I need the answer from your side. Please read the question and please let me know what is given perfectly, because you are going to find two answers. Let's we just read what is given. The 15 kilogram package is moving at a speed of 10 meter per second vertically upward along the y-axis. That means you can consider I have one object and this object mass is given, which is nothing but I am going to take capital M. What is the mass? 15 kilogram. Clear? And it is coming with a speed. What is your initial speed of this mass? The initial speed of the mass is given as 10 meter per second, and it is moving in the vertical direction. It is moving in the vertical direction. Clear? So what is the unit vector for this speed? The unit vector for the speed is j cap. Am I right? Am I right or not?
Of course, teacher, you're right.
Yeah. Okay. Now what will happen? This object, when it is moving in the upward direction, it is exploded and it becomes three parts. So what are the first part? The first object is exactly moving which direction? It's mentioned moving upward. So the first object, what is the mass of the first object? The mass of the first object is 2 kilogram. It shot upwards. That means the first object is moving in the upward direction because it exploded and it becomes three parts. So the mass of the first object is 2 kilogram. And what is its speed? Its speed is also given. What is its speed? 20 meter per second, and it is moving in the upward direction. Again, it becomes j cap. Am I right?
Yes.
Okay. What about the second object? What is about the second object? The second object has the mass 3 kilogram and it is moving in the positive direction of the x. That means the second object is moving in the positive direction of the x. So my second object mass is 3 kilogram and its speed is given as v2, and what is the value? It is 5 meter per second, and which is moving in the x direction, which is nothing but I cap. Am I right?
Yes, teacher.
Okay, then what about the third particle? Because third particle information is not given, suppose you consider the third particle is here. What is the mass of the third particle, brother?
The mass of the third
Yeah.
should be 5
How it is?
kilogram.
How it is 5?
Sorry, not 5.
How it is 5?
10.
10. Because the total mass is 15. Your first object is 2 kilogram. After exploded, first object is 2 kilogram. The second object is 3 kilogram. What is remaining? 10 kilogram is remaining. So that is nothing but your third object. Am I right?
Yes.
So we don't know what is the speed of the third object. That is our question. So for first question, we are going to find what is the value of this V3, and what is your second question? We are going to find what is the total kinetic energy. It's a very easiest question, but you should be very, very careful. Okay. First of all, I am going to apply the law of conservation of momentum for the collision. So initial momentum, which is equal to final momentum. What is my initial momentum, brother? This is our initial momentum, right? So initial momentum. What is my initial momentum? Capital M d naught, which is equal to final momentum. What is my final momentum? M1 v1 plus M2 v2 plus M3 v3. Am I right?
Yeah. Yes.
Okay. Now M value you know, which is nothing but 15 kilogram. What is your V0? Which is nothing but 10 meter per second j cap. What is your M1? 2 kilogram. What is your V1? 20 meter per second. What is your M2? 3 kilogram. What is your V2? 5 meter per second. What is your third mass? It's nothing but 10 kilogram. We don't know the value of this V3, right? So what you have to do, you have to rearrange this equation. So how to rearrange this equation? I'm going to keep this M3 V3, which is nothing but M1 V1 plus M2 V2 over M V0. Am I right? No, I don't know. I think this is negative. Am I right? Just a minute.
I should believe yes, teacher. Should be
It will be negative. Just a minute. Because if you change the sign, everything will be collapsed. So you should be very, very careful. You can just do it again. So I am going to find this. So what I will get? M1 MV0, and this term will come this side. So this becomes minus M1 V1, and this term is also coming this side. This is minus M2 V2. And right hand side I have M3 V3. Therefore, my V3, which is equal to MV0 minus M1 V1 minus M2 V2 over over M3. Am I right? Now you have all the values. When you substitute the value, you will get the answer for V3. Am I right?
yes.
So I already calculated. Later on, you can check the answer. When you substitute the value, I got the answer as 11.10 meter per second. So this will be the answer for the first question. Clear?
Yes, teacher.
Okay, let's become for the second question. What is given in the second question? The total kinetic energy. What is the total kinetic energy, brother? Apply the kinetic energy for this. So initial kinetic energy, which is equal to final kinetic energy. So what is my initial kinetic energy? Half m v0 square, which is equal to half m1 v1 square. Second particle half m2 v2 square, and third particle half m3 v3 square. Am I right? So that is nothing but this is your initial kinetic energy. This is your final kinetic energy. Am I right?
Yes, teacher.
Okay, now when you substitute the value, because you know the value of mass, you know the value of initial speed, likewise you know all this information, because just before we find the value of V3 in the first question. Am I right? When you substitute the value, brother, when I just substitute the value for the initial category, I got the answer as 750 joules. Likewise, if I just apply the value for the right hand side of the 1053.55 joules. Now you can see, brother, my left hand side of the equation is not equal to the right hand side of the equation. Am I right? Am I right?
Yes.
So I think there's something wrong.
Listen, brother, it's not something wrong, it's correct. Because now could you please tell me what type of collision it have? Suppose if I got 750 joules and 750 joules, suppose if I got 750 joules and 750 joules, what type of collision here we have? Now if both left hand side and right hand side are same, then what type of collision we have? We have
Elastic collision.
if the left hand side is not equal to the right hand side, what type of collision we have?
Inelastic collision.
Inelastic collision. So as per this answer, what type of collision we have in this question? We have only inelastic collision, because we already studied in inelastic collision, kinetic energy is not conserved. So my left hand side is not equal to right hand side. Clear?
Oh yes, okay.
Clear? So I can just erase this. So the type of collision for this question is inelastic, but what they need the total kinetic energy. So what is the formula for total kinetic energy? The total kinetic energy is nothing but final kinetic energy. Final kinetic energy. All right? Kinetic energy 1053.55 joules minus my initial kinetic energy is 750 joules. When you substitute here, my total kinetic energy of the collision is nothing but
303.55 joule. But teacher, he asked for the total.
Of course. What's the total?
Total, I
Doctor,
think we supposed to add it, no subtract it.
Brother, how you will add, brother? Initial moment, initial speed, final speed. So you have to subtract the total. What is your net? They are just clearly mentioned. What type of what type of information they are just given here? Total kinetic energy provided by the explosion. That means before explosion and final explosion. So when you just subtract the final explosion with the initial explosion, you will get the total explosion. Am I right?
Yes.
That's what I just subtract the final minus the initial.
we know the kinetic energy. It's always conserved. Here, why it's not conserved?
Because this is inelastic collision.
Okay, elastic collision. Where is the other energy? Where is gone?
Where is gone means what type of brother? Have you listened the class properly?
Yes, I know it's.
What is the okay?
It's,
Just give me the answer. What is the difference between elastic and inelastic?
the difference. I don't know how to say it.
Brother,
1 minute.
elastic collision, your momentum is conserved, your kinetic energy is conserved. Am I right?
Yes.
In inelastic collision, your momentum is conserved, but kinetic energy is not conserved. As per our answer, my left hand side of the kinetic energy is not equal to the right hand side of the kinetic energy. So this is not elastic collision. This is inelastic collision. Understand?
This the Schuster of.
Yes.
Right.
Actually, this is inelastic collision. This is inelastic collision.
Okay. Thank you, doctor.
Okay. Any other question, brother?
Thank you, doctor.
So explanation is given here, but take a practice. Okay. Okay. Let's come for our last question. It's very easiest question. It's very easiest question. Read the question. Better I can draw the diagram. If I just draw the diagram, you will get some idea. So this question is related with the bullet and the wooden block. So you have a bullet. That means you are triggering the gun. Bullet is coming out of the gun and it is going to hit the block. So initially the bullet has the speed of 700 meters per second. It is going to hit the wooden block which is at rest. That means your wooden block is at rest now. So if I just draw the diagram, the bullet. So I can just draw the bullet here. So this is my bullet. It is coming with some speed. What is the speed? So I can take my mass of the bullet is 5.2 gram. What is the speed? So V1I. That means the initial speed of the bullet. What is the initial speed of the bullet? 700 meters per second. Am I right? And it is going to hit the wooden block. What is the mass of the wooden block? So this is my wooden block. What is the mass of the wooden block? M2, which is nothing but 700 gram. And what is the speed of the wooden block?
At rest.
Zero.
Zero.
It is at rest. Very good. So it is at rest. So it is 0 meter per second. Here. And then after this bullet hit the block, it penetrates to the block. That means it is going to inside the block of the wooden block, and after that it is going outside. So when the bullet comes and hit the wooden block, after it hit, the wooden block will move a little bit. Am I right? Right or not?
Slower due to the pass through the
Brother, listen carefully. One person is standing, another person is coming with some speed. When the person coming with speed, when he is going to hit the person at rest, what will happen? The second person is moving with some speed. Am I right?
teacher.
So likewise, the bullet is coming with a speed and it is going to hit the wooden block at rest. After the bullet hit the wooden block will move with some speed. Am I right or not?
Yes, it should be. How can I say it? It will impact.
It will be moving little. Am I right? So now you can see my wooden block mass is m2, but it has some final speed also. Am I right?
Yes, you're right.
And also the bullet also have the mass and it has some final speed. So the mass of the bullet is 5.2 gram. And what is the speed now? After it hit, what is the speed? By M1 final, which is given as 450 meter per second. Right? What is my mass of the wooden block? My M2 value is 700 gram. So what is the V2F value? We are going to find. That is our first question. Clear?
Clear.
Okay, now I'm going to apply the conservation of momentum. What is the conservation of momentum? Initial momentum, which is equal to final momentum. Could you please apply the momentum formula here? So if you apply the momentum formula, M1 V1I plus, I'm going to apply the momentum here, M2 V2I, which is equal to M1 V1F plus M2 V2F. Am I right? Am I right or not?
Teacher, you're right.
Right, doctor.
Okay, now
Right.
you can see my wooden block is at rest. So this term, when you just multiply by 0, this term will gone. Am I right?
Yes.
Okay, now I'm going to rearrange because we are going to find only the V2F. So I'm going to keep this term M2 V2F, which is equal to, I'm going to move this term to the left hand side. So what you get, M1 V1I minus M1 V1F divide. Okay, so you will get like this. And then finally, I'm going to find V2F, which is equal to M1 V1I minus M1 V1F divided by M2. Am I right?
Yes.
So you have all the values. You have the value of M1, you have the value of V1I, you have the value of M1, you have the value of V1F, you have the value of M2. When you substitute the value here, you will get the answer of V2F. Am I right?
Of course, teacher, you are right.
The 1.86 meter per second. Later on, you can check the answer.
Yes.
Okay, now, so this will be the answer for the first question. Let's come for the second question. What is given in the second question, brother? It's very easy. What is given in the second question? What is the speed of the bullet block center of mass? That means we are going to find V center of mass. We are going to find V center of mass. Okay, what is the formula for V center of mass? Go to the slide. What is the formula for V center of mass? This is our V center of mass formula. Am I right?
Total mass in the bottom. And,
Yes. Okay, so
yes.
I'm going to use this formula for our second part of the last question. So, okay, I'm going to use this formula. So either, brother, this is your equation. Either you can consider the first half or the second half, you get the same answer. So I am going to consider before the collision. So V center of mass, which is equal to M1 V1I plus M2 V2I divided by M1 plus M2. Am I right? This is my left hand side. What is the right hand side? V center of mass, which is equal to M1 V1F plus M2 V2F over M1 plus M2. Am I right? Am I right or not?
Of course, teacher, you are right.
Okay, now if you substitute the value here, if you substitute the value in the first equation, you will get the answer of 5.16 meter per second. If you substitute the value here also you will get the value of 5.16. So either you can consider before hitting or after hitting. So you will get the same answer for the center of mass of the speed. Clear?
Yes.
So explanation is given here. You can see the right hand side of the, you can see the second question. What I written here, to find the speed of the bullet block system, you can consider either before collision or after collision. If you consider before collision means you have to take this part. You have to take You have to take this part or this part. When you just consider the left hand side and the right hand side, you have to get the same answer. Clear?
Yes.
That's it. Your chapter 9 is over. Any other question from your side?
No, teacher. Thank you.
Okay, brother. Listen carefully. Once again, I just tell the same information regarding your quiz 2. So your quiz 2, I plan to conduct in week number 11. Chapter,
When,
I
teacher?
think
When?
week number 11. Week number 11. This is your 9th week.
9.
Yeah, because midterm week is your 8th week. You already finished your midterm last week. Am I right? So this week is 9.
Yes.
So still 2. So prepare well. I hope 2 chapters will be considered for your quiz 2 portion. So inshallah today I have the class I have lab classes. I will discuss with other teacher how many chapters we have to consider for our quiz 2. Whether it is 2 chapters or 3 chapters. Generally, we will consider two chapters for the quiz 2.
The chapter. What's the chapters we will study?
Chapter 7 and 8, I think so. But anyhow, no problem, brother. Don't worry about your don't worry about the chapters for the quiz 2. I will discuss today and I will give the information in your blackboard announcement. Okay.
Okay, teacher. What should we bring with us tomorrow to the lab?
Tomorrow you have lab with me.
Yes.
Okay. Tomorrow you
Yes.
can come with the paper experiment number 4, Hooke's law.
Hooke's law.
Number 4.
Experiment
Just
number
number
4.
4, right? Doctor,
yes,
just
yes.
number 4.
Experiment number 4. Experiment 5 you already finished.
Yes, but did we finish Hooke's law?
Hooke's law. No, Hooke's law you didn't finish.
Doctor,
Yes.
the last lab I don't send it. I have problem. I give you on.
What you are talking about, brother?
The last lab.
You are saying.
I think it's 5,
No, 6.
6.
Sixth experiment, your teacher is Dr. Kessinger, so you have to send to him.
No, I am with you, doctor.
What's your lab class? Period number?
103.
103.
1, 2.
2, 3, teacher. 115. 6 and 115.
Yeah.
115. I think tomorrow you have the lab.
Yeah. I have
Okay.
problem. I give you this.
Okay, no problem. When you come for the lab, come with the paper. Okay.
Okay. So I'm sorry, doctor. I am late because when I am it's 6 p.m. I have my alarm 4 p.m. When I wake up 8. I see my alarm. I think I have 4 a.m. not p.m.
Very good.
Yeah.
Okay, no problem. When you come for the lab class on Thursday, come with the paper.
Yeah. Okay. Thank you, doctor.
Okay, brother. So please prepare well for your quiz too. I think we already finished chapter 7, 8, 9. So
Yeah,
you are ready for any chapters. If it is 2 chapters, 7 and 8. If it is 3 chapters, 7, 8, 9. Okay. Inshallah, I will discuss with our group members. I will give you the clear announcement in the blackboard.
Okay.
Okay, brother.
Please make it easy, doctor.
Brother, making your life tougher. What can I do?
It's very hard, doctors, learning.
Problem. No, it will be easy. I will make easy this question. Don't worry.
Thank you, doctor.
From the slides. Okay. So please prepare well. The question will be exactly based on the type of problems what we discussed in the class.
Okay, thank you, doctors.
Okay, brother. Take care. See you.
See you.
Assalamu alaikum.
See you, teacher. Have a nice day.